Okay, welcome to this video on our holiday homework. It's going to be a great summary of all of the skills in polynomials. So we'll start here. We're solving the following quadratics via factorization. So with this first one here, we can see we've got two terms. So all we need to do there is go, what's common to both of these? We can see that x is common and the number 4 is common. So we'll factorize 4x, and that will leave us within brackets, we'll have x plus 4. The way we can check that we're on the right track is that if we expand this, 4x times x would give us the 4x squared, and 4x times 4 would give us the 16x. Then we apply the null factor law. 4x is 0, or x plus 4 is 0. This gives us x is minus 4, and this gives us x is 0. Those are the two values of x that satisfy this equation that give us the solutions. Okay, moving on to this one, we have x squared plus 6x plus 8. This is a monic quadratic trinomial. So we're looking for two numbers that multiply together to give us 8 and add together to give us positive 6. So that's going to be x plus 4 times x plus 2. All right, so we can check by performing the FOIL, by doing the FOIL expansion, but hopefully we're pretty familiar with solving the monic quadratic trinomials. We're going to apply the null factor law. X plus 4 is 0, or x plus 2 is 0. So this gives us two solutions. X is minus 4, or x is negative 2. Both of those x values will satisfy our equation here. Okay, then we're on to C. We have 7x squared plus 6x equals 1. Now what we want to do here is we want to first move everything to the left-hand side. So firstly, we would have 7x squared plus 6x take 1 is equal to 0. So we've moved it to the left-hand side. Then what we're going to do is the slide and divide rule. So I'm going to take this number here and multiply it by this one over here. So what's going to result when we do that is we would have x squared plus 6x take 7. Okay, so we've taken the 7 and multiplied it by this one over here. And then we're just going to factorize that like we would a normal quadratic trinomial. So two numbers that multiply together to give us minus 7 and add to positive 6. So those two factors are going to be positive 7 and negative 1. Now because we multiplied by 7 up here, we have to divide both of these factors by 7, right? Now 7 divided by 7, that's going to give you positive 1. And over here, x take 1 on 7, we can't simplify that any further. We can't simplify that fraction. So the 7 comes up in front of this x. So this factor becomes 7x take 1. All right, now the way to check that we've done the slide and divide rule correctly is again expansion. If we expand this, we will get the initial equation that we started with. We then apply the null factor law and we get the solutions. X is minus 1 for this one, or we would have 7x take 1 is 0, which gives us 7x is 1, which gives us x is 1 on 7 is the other solution. Okay, so that's going to be it for question C. Let's move on to question 2. We have solved the following quadratics by completing the square. So the first one we have is x squared plus 2x equals 5. Now the way we complete the square is we add b divided by 2 squared to both sides. So b corresponds with 2 in this circumstance. And so we add b divided by 2 squared to the left side. And because we've done it to the left-hand side, we then have to do it to the right-hand side as well. All right. Now, what's going to happen on the left side is we have this x squared plus 2x plus 1 squared. And on the right side, we'd have 5 plus 1 squared. This is a perfect square, so it will factorize to become x plus 1 squared. On the right-hand side, we have 5 plus 1, that is 6. Then what we would do is square root both sides to get x plus 1 by itself. This gives us x plus 1 is plus or minus the square root of 6, because we can have the positive solution or the negative solution. And so we'd get x is negative 1 plus or minus the square root of 6. So the values of x that satisfy this equation, negative 1 plus the square root of 6 and negative 1 take the square root of 6. Those are the two solutions. Okay, on to b. If we're going to complete the square, we will add b divided by 2 squared to both sides. So in this circumstance, b is 6. So we have 6 divided by 2 squared to the left side, and then we're going to add that to the right side as well. Okay, so b divided by 2 squared to both sides. On the left side, this simplifies to x squared plus 6x plus 3 squared. And on the right side, we have 2 plus 3 squared. On the left side, we've manipulated it so that we have a perfect square. It's going to collect to be x plus 3 squared. And on the right side, we'll have 3 squared is 9, so 2 plus 9 is 11. We then square root both sides. So we'd have x plus 3 is plus or minus the square root of 11. And then we'll move the 3 over to the right side to get x by itself. Minus 3 plus or minus the square root of 11. Okay, so the solution to this quadratic is minus 3 plus or minus the square root of 11. Now we've got 2 more to do, 2 more quadratics to solve, and then maybe I'll just point out how we can use technology to help us to generate some solutions as well. So in 3, we are solve the following quadratics using the quadratic formula. So the quadratic formula is x equals minus b plus or minus the square root of b squared take 4ac divided by 2a. Okay, now for both of these quadratics, here we have a is 1, b is positive 1, and c is negative 5. Okay, the coefficient of x squared is 1, the coefficient of the x term is 1, so we have b is 1, we've got a is 1, and c is minus 5. So we're just going to substitute that into the formula. We would have minus 1 plus or minus the square root of 1 squared, take 4 times 1 times negative 5. Okay, so we substitute the values in exactly, and that's all divided by 2 times 1. Okay, so we'll have minus 1 plus or minus the square root of 1 take away minus 20, that will become, so it becomes 1 plus 20, that becomes 21. All right, and that's all on top of 2. And that's as simple as we can take that. We'll accept full marks at that stage. Okay, over here we would have a is 7, b is minus 5, and c is positive 1. A is 7, b is minus 5, c is positive 1. So we would have x is minus the b value plus or minus the square root of the b value squared. Take 4 times a is 7, and c is 1. And chuck that square root over the top. And that's all on top of 2 times a, where a is 7. Okay, we'll process this. Minus minus 5 is positive 5. And here we're going to have 25. 5 squared is 25. Take away now 4 times 7 times 1. That's going to be 28. 4 times 7 is 28. And here we can see we're approaching a roadblock, right? Because what we have, 25 take 28, that's going to be negative 3. And the square root of negative 3 has no real roots. So that's what we're going to say for this quadratic. It has no real solutions. Okay, so we use both of, so there's no values of x that satisfy this quadratic because we have the square root of a negative number here. Over here we have the square root of a positive number, so that's a legitimate solution. Now, as far as using our calculators go, what we'll do is we would go to equation solver. We can go into polynomial. The degree is 2. All right, for a quadratic, the degree is always 2. And then we're just inputting the values of a, b, and c. So we could do it for question 1b up here. We would have a is 1, a is 1, b is 6, c is 8. So we could input those and get the solutions. X is minus 2 and x is minus 4. Or we could even do it down here, like if we type in the first quadratic formula we did, we had a was 1, b was 1, c was minus 5. Minus 5. And so we've got minus 1 plus the square root of 21, or minus 1 take the square root of 21. Okay, both of those are the solutions. If we type it in this one, the quadratic would tell us no real solution. So we had a was 7, b was minus 5, c was positive 1. No real roots. Okay, that's what we said. No real roots, no real solutions. Very good. So that's question 1, 2, and 3. Let's move on to question 4. And in question 4, we've got two parts to it. For the following quadratics, so we've got this one here to start with, identify the y-intercept. Okay, so I'm just going to start with this one first. We have x squared plus x takes 6. That's the equation. Now, the y-intercept occurs when x is 0. So the answer to part 1, the y-intercept is -6. Okay, part 2 says factorize the quadratic using the cross method. So this means we're looking for two numbers that multiply together to give us -6 and add together to give us +1. Okay, so for this quadratic, it's going to be +3 and -2. All right, +3 times -2 gives us -6, and +3 plus -2 gives us +1. So we would have, if we're going to factorize the quadratic, it becomes x plus 3, x take 2. So that's our answer to part 2. Part 3 says complete the square. All right, so we're going to take this quadratic and we're going to complete the square for it. Now, this process is going to be a little bit different from the previous question where we were completing the square, because what we have to do here is we don't have it equals to 0. So when we complete the square for this one, what we're going to be doing is we can see the value of b is +1. So what we're going to do is we're going to add +1 squared, +1 divided by 2 squared. Now, because we added it here, we also then subtract it. And all I want to say is that this equation that we've written here is the same as the equation in this step, because +1 on 2 take 1 on 2, those would cancel, and so it remains the same. We're just performing a little bit of mathematical manipulation to point out that it can be expressed like this. Now, this is a perfect square. We've manipulated it to be such. So this would complete to be x plus half squared. And then over here, we would have take away 6, take away half squared. Now, half squared is a quarter. So we have take away 6 and a quarter, take away 6.25. Right, that's what that will collect to. So when we complete the square for this quadratic, this is how it can be expressed. All right. Part 4 then told us, okay, now find the roots. Okay, now from here we could find the roots two ways, right? The roots occur when the function is equal to 0. Okay, so we could set this quadratic equal to 0 and just apply the null factor law, and we can see that the roots would be -3 and +2. They're the two values of x. We'd have x plus 3 equals 0 or x take 2 equals 0. They're the two values of x that will give us the roots. The other way we could do it is if we set this equation equal to 0, and then just like we did on the previous page, moving the 6.25 over the square root of both sides and then subtracting half. That's going to give us the same solutions as well. So either process will work. Definitely from the cross method is much cleaner because of the nature of this particular quadratic. Okay, so part 4, we've identified the roots. Part 5, identify the axis of symmetry and the coordinates of the vertex. Okay, so for the axis of symmetry, I think there's two ways we can sort of draw this out. The first is that the x value of the axis of symmetry is -b on 2a. We're familiar with that equation that describes the x value of the axis of symmetry. So we could have -1 divided by 2 times 1. So in this circumstance, yep, -1 divided by 2. That's the x value of the axis of symmetry. Now that is further displayed to us by the perfect square form here. Like one way that this is expressed, this tells us the coordinates of the vertex. All right, the vertex is, when we express it in completed square form, we have x take h squared plus k, right? And what we have here is x take -half squared, take 6.25. So we have x take -half squared, and then we have like plus -6.25. So in this circumstance, right, the value of k, that's the y coordinate of the vertex, that's -6.25, and the x coordinate of the vertex is -half. So we can see it from the vertex form. So part 5 is asking for the vertex as well. So we'll answer that here. The vertex is -half minus 6.25. And of course, the third way that we can get it is that the axis of symmetry occurs exactly halfway between the roots. All right, so we could add the roots together, minus 3 and positive 2, and then halfway between them, we divide it by 2. That's going to give us the same as minus 1 on 2. That's the x value where they occur. So there's three ways that we can sort of think about the axis of symmetry, and we've already got the coordinates of the vertex from the completed square form. Okay, and then part 6 says plot it on the Cartesian plane. So what we have then is we have a y-intercept of minus 6, so that's going to be down here somewhere. We have roots of x is minus 3 and y is positive 2. We have a vertex of minus half and minus 6.25. So that's the turning point down here. So we'll sketch that with all those features. Here's the quadratic. Now, in order to get full marks for a graph, we want to make sure we label our axes. We label the graph. Now, we could label it like that. We could label it like that in linear factor form, or we could even label it in completed square form. Doesn't matter. But we just want to list all of those things, right? We have the axis of symmetry is x is minus half. We have the coordinates of the vertex is minus half and minus 6.25. All right, we have the y-intercept is minus 6, and we have the roots are x is positive 2 and x is negative 3. And then we've effectively displayed all of the features that we evaluated in the graph there, haven't we? Okay, so that was question A. Let's have a look at B, and I'm going to have to do it on a different piece of paper. Now for B, what the equation that we had was this one, y equals x squared, take 6x plus 5. Okay, the first thing that we're asked to do is what's the y-intercept? So the y-intercept is positive 5. Y-intercept occurs when x is 0. Okay, then we were asked to factorize the quadratic using the cross method. So two numbers that multiply together to give us positive 5 and add together to give us negative 6. That's going to be x take 5 and x take 1. Minus 5 times minus 1. Very good. Then we're asked to complete the square. So remember, when we're completing the square, what we're going to do when we don't have it equal to 0 or equal to a number, what we're going to do is we're going to add b divided by 2 squared. And because we added it, we then have to subtract it. Okay, so plus 6 divided by 2 squared and take 6 divided by 2 squared, they would cancel, so it's still the exact same expression. Now 6 divided by 2, that's going to simplify to 3. Okay, if we can simplify it, we should. And then we have plus 5 and then take 3 squared. Now, because we have this negative here, when we complete this square, it's going to complete to x take away 3 squared. All right, in the previous circumstance, we saw we had a positive. All right, so when we completed the square, we have the positive there. Here we have the negative, so it's going to complete to x take 3 squared. And then we have plus 5 take 9. 5 take 9 is minus 4. So we've effectively completed the square there. Now, all we're doing is we're saying we've got this quadratic. We can present it like that. We can present it like that in linear factor form, or we can describe it as a perfect square. Okay, part 4 says identify the roots. Well, the roots occur when it's equal to 0. So if we set this equal to 0, we can apply the null factor law, and we can see that the roots are x equals 5 or x is positive 1. So we have 2 roots there. Then for part 5, we're asked to identify the axis of symmetry. All right, so the axis of symmetry, we've seen there's a number of ways we can do that. Let's do minus b divided by 2a. So in this circumstance, it's going to be minus 6 divided by 2 times 1. And that's going to give us positive 6 on top of 2, which is 3. That's the x value of the axis of symmetry, which we can get from that equation. But we can also see it from the vertex form, from the completed square form, right? That's the x value of the axis of symmetry. The coordinates of our vertex are x is 3, y is negative 4, and then we're ready to sketch that on the Cartesian plane. So for this quadratic, we have a y-intercept of positive 5, We have roots at x is 1 and x is 5. We have a vertex at x is 3, y is minus 4. All right, so the parabola has this shape. Okay, again, to get full marks for a graph, we need to make sure that we fully label it. We have x squared take 6x plus 5. And the roots of this quadratic are x is 1 and x is 5. We can have an appropriate scale in here. 1, 2, 3, 4, 5. We have an axis of symmetry. That's the line about which the parabola is symmetric. At x is 3. The coordinates of the vertex is x is 3, y is minus 4. And we have a y-intercept of 5. So all of those features we've calculated in the question 4. All right, let's move on to question 5. We have determined the equation of the following quadratics. So what we can see about this one is we have a vertex at minus 2, minus 4. So I'd be inclined to use vertex form here, where we would have the default vertex form is this, y equals a times x take h squared plus k, where hk is the coordinates of the vertex, right? So in this circumstance, we would have y equals a multiplied by x take minus 2, all right, x take the x coordinate of the vertex, and then plus the negative 4, so take 4, plus the y coordinate of the vertex, okay? Then what we would do is simplify that, and we need to substitute a point in. This one's probably going to be easiest. We have when x is 0, y is 0. So that's going to give us, I'm going to put 0 where the y is and 0 where the x is. We would have a times, now minus 2 is just positive 2. And we're solving this equation for a. We'd plus 4 to both sides. And then divide both sides by 4 gives us a is 1. Therefore, this quadratic in completed square form would be x plus 2 squared, take away 4. All right, so that's all well and good. However, it does say determine the equation in this form. Now that's general form, isn't it? So that means what we would need to do is fully expand this out. So we have x plus 2 squared take 4. Now, if we are going to fully expand that, what that would look like is we would have x plus 2 squared take 4. We're going to use the perfect square rule. Okay, remember this. If we have a plus b squared, it's a squared plus 2ab plus b squared. So here, x corresponds with a and b corresponds with 2. So when we fully expand it, we would have x squared plus 2 times x times 2 plus 2 times a times b plus b squared. And then we have this take away 4 just hanging out, right? So this part expands to here. That's the perfect square rule. And then we have take away 4. Let's simplify it. X squared plus 2 times x times 2, that's 4x. And then we have 4, take 4. Well, they're just going to cancel one another, aren't they? So this quadratic is x squared plus 4x. Okay, so those are the multiple ways of presenting it. Let's move on to this one. And this one we can see very clearly we've got two roots. We've got minus 3 and positive 1. So we're going to use linear factor form, which is like this. A times x take p times x take q, where p and q are the roots. So in this circumstance, we would have y equals a times x take 1, all right, for that root, and then x take minus 3 for that root. All right, and then we're going to sub in any other coordinate that we're presented with, a piece of information we haven't used, this one, which is when x is 0, y is positive 3. So we'll put 3 where the y is, and we'll put 0 where the x is. Okay, so this gives us 3 equals minus 3 times a. So we divide both sides by minus 3 to get a is negative 1. So in this circumstance, we have a is minus 1. Now, if we're going to fully expand this one, all right, so what we're going to use here is FOIL. we have the equation of this quadratic is minus 1, x take 1, x plus 3. That's it in linear factor form, but remember this question has asked us to present it as a general form. So what I'm going to do, I'm going to leave the negative out the front for now. We'll distribute that later, and instead all I'm going to do is perform FOIL for these two brackets. So we're going to take x and multiply it by both of these. X times x is x squared. X times 3 is positive 3x. And then we're going to take the second term, minus 1 times x is minus x, and minus 1 times 3 is minus 3. Okay, so we can think of it as FOIL, or you can think of it as this term has to multiply both of those, and this term has to multiply both of those. Okay, then we'll just collect like terms in the brackets. So that would be x squared. These two are like terms. 3x take x would be negative positive 2x. We have 3 lots of x, take away x gives you positive 2 lots of x, and then we have take away 3. Now the negative will distribute. We'll have minus x squared, take 2x plus 3. Okay, and that's that quadratic in general form for us. What that can reveal to us, we can see the y-intercept, we can see the negative a value means it will open downward, just like we had in this graph here. We expected it to be negative. Okay, then we're on to 7. Use the discriminant to determine the nature of the roots. So just a quick recap on the discriminant. We have the discriminant is b squared take 4ac, and it's the inside of the quadratic formula, right? And if the discriminant is positive, we have 2 real roots. If the discriminant is 0, we have 1 double root. That's where it touches the graph, 1 double root. And if the discriminant is less than 0, then we have no real roots. So all we're going to do is evaluate the discriminant and see which of those it satisfies. Here in A, the discriminant would be b squared. So 10 squared, take away 4 times 1 times 25. That leaves us with 100 take 100, which is 0. So in A, the discriminant is 0, and if the discriminant is 0, we have 1 double root, 1 solution. Okay, here we would have, we're going to do b squared, so we'd have minus 3 squared. Take away 4 times 1 times 7. So that's going to give us positive 9, take away 28. That gives us minus 19. The discriminant is negative. So in question B, there are no real roots. This means the quadratic does not cut the x-axis. No real roots. On to C, we have x squared take 5x plus 6. So we'll find the discriminant. We would have minus 5 squared, take 4 times 1 times 6. So that's going to be 25, take 24. That gives us positive 1. That means there are 2 real roots, 2 real solutions. And there's something further as well. The discriminant is a square number. Okay, so remember the square numbers, those are going to be 1, 4, 9, okay, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, these are the square numbers. And because the discriminant is a square number, it means the roots are rational. It means you can solve this quadratic via factorization. All right, so that means something extra as well. Okay, part 8. Use the discriminant to determine the relationship between the graph and the x-axis for the following functions. All right, so if we're going to find the discriminant of this one, we would have b squared, take 4 times a times c. Now the c value is positive 4, so this gives us 9 take away 16, which is minus 7. So we have the discriminant is negative, right? And we also have the a value is 1. The a value is positive, all right? So this means 2 things. It means it opens upwards and that it has no real roots. So if we think of the graph of this quadratic, okay, it's going to be completely above the x-axis, all right, because it never crosses it, it has no roots, That's shown by the discriminant being negative, and the fact that it opens upwards means it has to be above the x-axis. It would have a y-intercept of positive 4. We haven't evaluated its axis of symmetry or anything like that, but just demonstrating it would be above. And we call this positive definite. Now, this is a special type of quadratic. In what it means is that for every x value, the y value will be definitely positive. It's always positive. It never goes below the x-axis. All right, so that's question 8. Let's move on to 9. Find the equation of the following quadratics in the form ax squared plus bx plus c. So the first one we have is it cuts the x-axis at 3 and minus 2 and passes through this point. So this would look at, that's linear factor form. All right, we would have y is a times x take p times x take q. Now, in the circumstance for a, we have it cuts at 3 and minus 2. So they're the roots. X take 3 and x take minus 2. And then we also know that it passes through 2 minus 4. That means when x is minus 4, when x is 2, the y value is minus 4. So we'll sub that in. The x value is 2, so we'd have 2 take 3 and 2 plus 2. And we'll just evaluate this. So we have minus 4 is a times 2 take 3 is minus 1. 2 plus 2 is positive 4. So we have minus 4 is minus 4a. This yields that a is positive 1. So the equation of this quadratic is x take 3 times x plus 2. However, it has asked for the quadratic in the form ax squared plus bx plus c. So we're just going to perform a FOIL here to solve that. So if we're going to FOIL, now that means that we would have x times x gives us x squared. X times 2 is positive 2x. Take away 3x and then take away 6. Okay, when we collect those together, we have 2x take away 3x. That gives us minus x take away 6. So this quadratic and this quadratic are the same. Here we've got it in linear factor form. Here we've presented it in general form. Okay, so that's the answer to part A. Let's have a look at part B. Find the equation of the quadratic that touches the x-axis at 3 and passes through 1, 8. Okay, so if it touches the x-axis, that means it's a squared factor. So it means it has this form, a times x take 3 squared. That's where it touches the x-axis. We also know that it passes through x is 1, y is 8. So we'll sub that in. All right, so this gives us 8, and we'll have here a times 1 take 3 is minus 2 squared. So we have 8 is equal to 4a. This yields that a has to be positive 2. So the equation of this quadratic then is 2 times x take 3 squared. And we are required to write it in general form. So that means we're going to fully expand this using the perfect square rule and then distribute the 2. So I'm going to leave the 2 out the front for now and use the perfect square expansion. X take 3 squared, that's the same as a take b squared. That's going to become a squared, take 2 lots of a times b, and then plus b squared. Okay, simplify that. The 2 can stay there for now, but it's going to be x squared take 2 times x times 3 is 6x, and then plus 9, and then we'll distribute the 2 into the bracket. 2x squared take 12x plus 18. Okay, so that's what that quadratic becomes in general form. So we had a here on the side, and we had b that we solved in here. Okay, moving on to 10. Find the point of intersection between this function f of x and this function g of x. Now all that means is we're finding out when do they cross one another. Now a simple way to do it would be to graph them and g-solve the point of intersection. So the functions are x squared take 5x plus 6 and 2x take 4. We'll graph them, we'll just set our v window to standard and just g-solve the points of intersection. Okay, so we can see they intersect when x is 2, y is 0, and when x is 5, y is 6. So we can see those solutions using technology. If we're going to find this manually, what we would do is we're going to equate these two equations together. So we would have x squared take 5x plus 6 is equal to 2x take away 4. Then we're going to move everything to the left-hand side. We want to know what are the values of x that make this true. So I'm going to take away 2x and take away 2x from both sides and plus 4 and plus 4 to both sides. Because what that does to us on the right-hand side is gives us 0. And on the left-hand side, we'll have x squared. We'll have take away 7x and plus 10. Then we're just looking to factorize this quadratic, right? Two numbers that multiply together to give us positive 10 and add to minus 7. That has to be negative 5 and negative 2. Minus 5 times minus 2 is positive 10. Minus 5 plus minus 2 is minus 7. And that's equal to 0. We'll apply the null factor law. That gives us x is 5 or x is 2. And then we want to know, well, what's the y value? Because we're looking for the coordinates. Now, both of these functions, because these are the x values where they meet, that means they're going to have the same y value at that point. So it's not going to matter which x value we use, whether it be x is 2, or it's not going to matter which function we use, whether it be the quadratic or the line, they both have the same y value. So let's find g of 2, that's going to be the y value when x is 2. So we'll put that in, it's going to be 2 times 2, take away 4, that's 4 take 4, that's 0. We'll also find g of 5. That means when x is 5, what's the y value? That's going to be 2 times 5, take away 4. So that's 10 take away 4, that's 6. So the coordinates become then, we have when x is 5, the y value is 6. And when x is 2, the y value is 0. And those are the 2 points that we observed on our calculator as well, right? X is 5, y is 6. And and x is 2, y is 0. Okay, on to 11. In here we have find the values of m for which this function, this quadratic, and this line have one point of intersection. Now, if there's one point of intersection, it means they're tangent, right? So just what it means is there's a quadratic, and we have the equation of a line that has a y-intercept of minus 7. So if we think, here's a quadratic. If I have a line that has a y-intercept of minus 7 and a slope of m, well, it could go like that, it could go like that, it could go like that. We want to go, what's the value of m such that it has one point of intersection, that it touches the curve? That's when it's tangent. Okay, remember m controls the steepness of the line. So we're going to start by doing exactly what we did. We're going to equate the two quadratics. 2x take 3 equal the quadratic and the line, mx take 7. Now we're going to take away mx from both sides and plus 7 to both sides. Now, what that's going to do is on the right-hand side, it's going to give us the 0, right? 7 take 7 minus mx plus mx. So we've got the 0 there. And over here, we're going to collect those. So that becomes m plus 2. All right, we have minus m, take away 2. So we can treat it as there's the negative there. There's a number of ways of thinking about it, but we'll keep it like that for now. So the whole b value is that thing. And then we have 7 take away 3. That's going to be positive 4. And that's equal to 0. Okay, so this is what the quadratic collects to. X squared take m plus 2 times x, and then plus 4. Okay, and it's like, well, how do we solve that? Well, we're not really interested in solving it, all right? What we're interested in is when does this quadratic have one solution? And what we saw before when we were talking about the discriminant, right, is that if the discriminant equals 0, we have one root, we have one solution. So what we're going to do is find the discriminant of this quadratic and make it equal to 0. Now the discriminant is equal to b squared. So in this case, it's minus m plus 2 squared. Take away 4 times the a value times the c value. And we want to know when does the discriminant equal 0. Okay, so there's a couple of things that are going on there. Firstly, we equated the quadratic with the line. We moved it over to the left-hand side and collected it. And now we want one solution. It says find when it has one point of intersection. So one point of intersection means one solution, which means the discriminant equals 0. When the discriminant is 0, we have one solution. Here we've got b squared, take away 4ac. And now we're going to solve this for m. We're going to say, what are the values of m such that there's one point of intersection? So the values of m then, will, if we perform a perfect square here, now straight away I've got that negative there and the squared here. The negative and the squared will cancel. So we can just focus on performing the perfect square expansion of this. That's going to be m squared plus 4m plus 4. Okay, that's perfect square expansion. And then we have over here, take away 4 times 1 times 4. That's going to be take away 16. All right. So this gives us m squared plus 4m take away 12. And then we're looking for two numbers that multiply to minus 12 and add to positive 4. So that's going to be positive 6 and negative 2. All right, positive 6 times negative 2 is negative 12, and we add them together, we get positive 4. And if we apply the null factor law here, we get m is minus 6 or m is positive 2. Just show you what that looks like on your calculator. So the quadratic was x squared, take 2x, and take 3. And if we have m is minus 6, all right, then this line would become minus 6x take 7. All right, so that's the case when m is minus 6. And you can see we have one point of intersection, all right, that it touches at once. If we had m is positive 2, then we'd be changing the slope of this line to 2. And we can see that, again, it has one point of intersection that it touches. Okay, so that's question 11. We're getting through them. So we're on to question 12, where we have a rectangular box, has a height of 5 centimeters and a volume of 280. One side of the base is 1 centimeter longer than the other. Okay, explain why the volume is this. So we have a box, all right, it's going to look something like this. And we have one side is x, and the other side is 1 centimeter longer. So this is going to be x plus 1. And then the height here is 5. Okay, now the volume of this shape, right, the volume of this whole shape, the volume of a rectangular prism is length times width times depth. So in this circumstance, that's going to be 5 times x plus 1, which is 5x times x plus 1. All right, now we also know that the volume is equal to 280 centimeters cubed. So we have the volume equals 280. All right, part B says find the dimensions of the box. So what we have to do there is we have to go, what's the value of x that makes this true? Now, in order to solve that, what we're going to do is expand this first. We would have 5x squared plus 5x. And then I'm going to move the 280 over to the left-hand side. Take away 280 equals 0. Now, we could try and factorize this or find the solutions using factorization. However, one thing we can do is just rely on our calculator, can't we? We said it's a polynomial, has a degree of 2 because it's a quadratic. We have a is 5, b is 5, and c is minus 280. The values of x that we get is x is 7 or x is minus 8. So they're the two values. Sorry, x is positive 7 or negative 8. Now, one of these we reject because it doesn't make sense in the context of the problem. And it's this one, isn't it? We're going to reject the 8 because you can't have a negative measurement. So we need to make sure we answer the question. The dimensions are going to be x, it corresponds with x is 7. So it's going to be 7 by this distance here will be 8. So the dimensions are 7 by 8 by 5. All right, length times width times height. Okay, on to 13. We have 1,200 meters of fencing is used to make 6 identical pens shown below. Explain why 12x plus 7y equals 1,200. Okay, so all we're going to say there is we have 12 lots of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 lots of x, plus we have 1, 2, 3, 4, 5, 6, 7 lots of y, add up to 1,200 meters of fencing. So we can just write that as a sentence for part A. For part B, show that the area of each pen is given by this equation. Now, I think this might be faulty. We'll just have a look in a sec. The area of each pen, right? The area of one pen equals x times by y, okay? The length times the width. However, the problem with this expression is that we have two variables, x and y. We want to reduce it down to a single variable. So what we have to do with these ones is we have to take our initial equation that we had in A, and we have to manipulate this. Now, what I'm going to do is solve through for y. So the first thing I'm going to do is take away 12x from both sides, and then we're going to divide both sides by 7. Now what that would give us is 1,200 on 7, take away 12 on 7, x. All right, so if I divide by 7 and divide by 7, divide all of the terms by 7, this is what it simplifies to. And now we're going to take that and we're going to plug it into the area equation. The area is x times y. So that means the area is x multiplied by 1,200 on 7, take 12 on 7, x. Now when we distribute the x, we get 1,200 on 7, x. Take 12 on 7, and this term becomes x squared. Okay, success. Says show that the area of each pen is given by this. And then part C says find the optimal solution. Now the optimal just means the best, the most economic, the one that's going to give us the maximum area, right? Well, we could graph that and G-solve it, but we also know from optimization that the vertex, the optimal solution occurs at x is minus b on 2a. Now, in this circumstance, the a value is negative 12 on 7. A is always the coefficient of x squared, and the b value is 1,200 on 7. Okay, so what we would be doing then is minus b on top of 2 times our a value, minus 12 on 7. That's what we're evaluating. Okay, now the way this would work, all right, we're just going to assign the negative to one number. It doesn't matter which one it belongs to, but it doesn't belong to both of them. It's either going to go to the top or the bottom. So what we've got is we've got minus 1,200 on 7. On top of here, we have 2 times, it's going to go to the minus 12, minus 24 on top of 7. And then we would just do A times D, 1,200 times 7 on top of B times C, 7 times negative 24. Now 7 will cancel because it's common to both the top and the bottom. And the negative will cancel. And we have 1,200 divided by positive 24. That gives us 50. So the x value that provides the optimal solution is 50. All right, if x is 50, then the y value is going to be 1,200 on 7, take 12 on 7 times 50. That's what y is. Y is proportional to x. So if we evaluate the y value, we would have 1,200 on 7, take 12 on 7 times 50. All right, so the y value we would get is 85.7. So the optimal solution then is when we have dimensions 50 by 85.7, that's going to provide the maximum area of each pen. Okay, that's our answer to 13. Okay, on to 14, and we have fully factorized this cubic given x equals 2 is a root. So if x equals 2 is a root, what that means is x take 2 is a factor. All right. So what that means is if x equals 2 is a root, x take 2 is a factor. Now we know this is a linear factor and that there has to be some quadratic equation here, ax squared plus bx plus c, that when we expand this, it has to equal this same cubic over here. All right, so the reason we know that's true, right, is because we have a linear times a quadratic gives you a cubic. We know this is a root, and so we know there's some quadratic factor here. What we're going to do is find the values of a, b, c, and then factorize this quadratic. So we have, first we'll expand this. So what we're going to do is take the x and multiply it by every term in this bracket. That's going to give us ax to the 3 plus bx squared plus cx. Then we're going to take the minus 2 and multiply that by every term in the bracket. Now remember, I like to do the staggered method, right? So I'm going minus 2 times ax squared. That gives me minus 2ax squared. And I say it's staggered because I'm writing it underneath this one, because they're both x squared terms. Then we'll do minus 2 times bx. That's going to be minus 2bx. And then we'll have minus 2 times c. That'll be minus 2c. We'll collect these together. And what it becomes is ax to the 3. We have b take away 2. That's times the x squared term. And c take away 2b. That's the x term. And then we have take away 2c. Now this cubic that we've expanded here, it's equal to this one here. All right. So that means we can start to equate some. We have minus 2c is minus 8. So that gives us c is positive 4 by dividing both by negative 2. We also have ax to the 3 is x to the 3. So that gives us a is positive 1. And we have b take away 2a, that should say, sorry, b take away 2a is equal to negative 7. So let's write that one out. b take away 2a is negative 7. We have the a value is 1, so that means b take 2 is negative 7. So we'll plus 2 to both sides and we'd have b is negative 5. So that means the equation of the quadratic factor is ax squared, so x squared, plus bx, so take 5x, and then plus 4. Now if we're going to factorize this component of it, two numbers that multiply together to give us positive 4 and add to negative 5, that's going to be minus 4 and minus 1, right? So that means this whole cubic, if we're to factorize it fully, the whole cubic would be x take 2 multiplied by this quadratic factor that we've put into linear factors. That's going to be the cubic fully factorized as linear factors. Roots at 2, 4, and 1. Okay, oh my gosh, we got 4 of these to get through. So find the equation of the following polynomials. So in 2a, we have it cuts the x-axis at 2, minus 2, and 3, and has a y-intercept of minus 24. So what that one's going to look like, I'm just looking around for some more paper, but maybe we'll try operate here. So just doing this one first. So it's going to be x take 2, x take minus 2, x take 3. Okay, those are the linear factors. And it has a y-intercept of minus 24. So that means when x is 0, so we're putting 0 where the x is, minus 2 is positive 2, and minus 3. When x is 0, the y value is negative 24. And we're just solving through for a, right? So that's going to be minus 2 times 2 is minus 4, times minus 3 is positive 12. And so this gives us the a value as minus 2. So the equation of this polynomial then would be minus 2 multiplied by x take 2 times x plus 2 times x take 3. Okay, so we just went, those are the roots, 2, negative 2, and 3, and plugged the y-intercept in and solved accordingly. All right, we have touches the x-axis at minus 3 and 2 and has a y-intercept of 36. So when it touches the x-axis, that means it's going to be a squared factor. So we have x take minus 3 squared and x take 2 squared. Y-intercept of 36 means when x is 0, so we'll put in 0 here, and minus 2 squared. So this is going to become 9 times 4, which is 36. And so we'd have a is 1. So the equation of this polynomial, which will be a quartic, we know it's a quartic because we have x plus 3, a quadratic factor, times another quadratic factor. All right, 2 quadratic factors multiplied together there. Okay, on to C. What we would see with this one is that it touches the x-axis at -1 and crosses at 2. So we would write that as x take 2 and x plus 1 squared, because that's x take -1, so that becomes x plus 1 squared. And we also have when x is 0, y is 4, so we put that in there. Okay, processing this gives us a has to be, we'd have -2a, gives us a is -2. Therefore, the cubic would be -2, x take 2, x plus 1 squared. Okay, so yeah, squared factor for the -1, so x take -1. All right, over here we have a flat cut. So that means that's a cubed factor. All right, we would have a times x take 0 cubed, and it then cuts again at 2 times x take 2. Now this can just be expressed as x cubed times x take 2. All right, we don't need to express it as x take away 0 because x take away 0 is the same as x. Then we're going to substitute in this coordinate. We have when x is -1, y is +3. All right, processing this yields, now -1 to the power of 3 is -1, and -1 take away 2, that's going to be -3. So -1 times -3 is +3. So this gives us a is 1. So therefore this polynomial, it's a quartic again because we have a cubic factor times a linear factor. That would be x to the 3 times x take 2. A is +1. Okay, really good. We made it through all of those questions in under an hour, so great work. If you have any questions, feel free to reach out and ask.